Right, now this problem, to tackle this problem, we need to use this result. That's the result for the nth root of unity. And for equation like this, solution will be 1 w squared and w to the power n minus 1, where w is just 2 pi over 5. Right, so you better recall this, and because we're going to use this result to help us to solve this problem. Change to this color. Now to find roots of this problem, I rewrite this as follow. And yes, you probably noticed that this is actually 2 to the power 5, 32 that is. So if you now divide both sides by 2 to the power 5, you get this by using the law of indices, and immediately this becomes this problem. Just that, of course, this is z over 2, but there's no real distinction. It means that z over 2, the solution to z over 2 is therefore 1 w squared and so on until w power 4, because this power 5 we have 5 solution, and in other words this is just 2 pi over 5, and then the third one is just 4 pi over 5, and then we have just 6 pi over 5, and then just 8 pi over 5. Okay, and of course we want to solve for z, so this is 2 pi over 5, 2 is 4 pi over 5, and this is 2 is 6 pi over n. The last one, 2 is 8 pi over 5. Now before we do part B to plot all these solutions, now note that they all lie on the circle of radius 2. So let's just try and draw a circle. Here, change this. Okay, get a circle on. Okay. Let me get this pen again. Get a circle. Okay, so something like this. So this circle is of a radius 2, and we know that the first one, 2, lies here. Z equals 2 lies here. So this is 2, and then the second solution, 2 is 2 pi over 5. 2 pi over 5 is actually 72 degrees. So means that it should be somewhere here. Right, because here should be 72 degrees, or 2 pi over 5. And the third one, 2 is 4 pi over 5, is roughly here. Okay, the size of this will be 2 pi over 5 or so. And the fourth one, now we know that the conjugate would present itself as in the solution. So the fourth one will be the conjugate of the third one, and so it will be right here. So because conjugate, there will be it's a reflection on the x-axis, if you recall, and the last one must be here, and because the last one, 2 is 8 pi over 5 would be the conjugate of the first one, this one. So this is a conjugate of each other, this conjugates, and this one and this one, these two are conjugates, and we label them, and let's call them Z0, let's call it Z1, Z2, Z3, and Z4. Right, so it's just cool. And lastly, just express this expression, this one, as a product of quadratic and linear factors. And we use the fact that Z2 and Z3 are conjugates, and Z1 and Z4 are conjugates to help us to form the factors. I need to move on to another page. Get the pen first. Okay, so Z0 is 2. There's nothing much we can do. So then from here we know that this will be one of our the linear factor, right? And then using so Z1 and Z4, they are conjugates, obviously, from the diagram you can see, because these two are reflections of each other on these the horizontal axis. So what we do is we get their sum of roots, right? So sum of roots for Z1 was 2 pi over 5 plus for Z4 2 8 pi over 5. In fact, this is actually 2 pi over 5, and this is plus 2, and 8 pi over 5, if you think about it, somewhere here, right? 8 pi over 5, this is it, 8 pi over 5. This angle here is actually negative 2 pi over 5, and if you replace 8 pi over 5 with negative 2 pi over 5, no problem with that. This is actually negative 2 pi over 5. If you expand this, this becomes cos 2 pi over 5 plus I sine 2 pi. That's no problem with that. But this one, this is 2 cos negative 2 pi over 5, which is 2 cos 2 pi over 5. Remember that, right? Remember that cos negative t is just cos t, and then sine negative t, yeah, it's negative sine t. So you have a plus, or rather minus 2i sine 2 pi over 5. So, and this is a 2 here. So these two terms will cancel each other. This one is a 2i, and then you have 4 cosine 2 pi over 5. And if you expand properly the product of roots of Z1 and Z4, you would get 4. Okay? And so this the quadratic factor formed by Z1 and Z4 is therefore Z square minus 4 cos 2 pi over 5 plus 4. Okay, and then now if you repeat this with Z1 and Z2 and Z3, right, the sum of roots would be 4 cos 4 pi over 5, and the product of roots, you try that and figure out why this is 4 cosine 4 pi over 5. Alright, it's the argument is similar to what we have here. And so the product of roots will be 4 also. So using Z2 and Z3, you will get this factor cos 4 pi over 5 plus 4. So therefore, this expression Z power 5 minus 32, this is your linear factor, and your two quadratic factors, 2 pi over 5 plus 4, And that's it. That's what you need to do